we're going to graph this function given this domain right here. And what I like to do is organize my information first. So my domain represents all the possible x values for my function. So I'm going to make an xy table because, actually put it in black. I need to make an xy table because we need points to draw this or to graph this function. And the points are made up of x and y values. So keep in mind, your domain are the x values. So I'm going to put that in my column for the x. So -2, -1, 0, 1, and 2. So that will be my domain. So that means I'm missing my range, my y values. And to get the y values, you have to evaluate each of these inputs. So I got to take each of these numbers, put it inside this function it gave me here, this equation, and get the answer. Whatever answer I get when I substitute x in here and get the answer, that's going to be my output. So, and that's going to make up the range once I get everything complete. So what we're going to do first is evaluate when x is -2. So I'm going to copy the equation. Y equals 1 minus x in parentheses. So we say the quantity 1 minus x squared. And now I'm going to substitute. Keep in mind, we're replacing x. So when you replace negative numbers, you got to be careful. So here we're going to put y equals 1 minus. Now notice that we have a minus on here, but we're replacing what's in blue, the x. And here x is -2. So it's a -2. So be very careful when you substitute, because a lot of times students or people mess up with the minus sign. They think that takes care of the negative, but it doesn't. So notice that I replaced x with -2. This does not, the negative does not take into account this over here. These are totally different. So we're replacing this number there. And now I get y equals, in the parentheses, I know 1 minus -2 is the same as 1 plus 2. And the last step, when I simplify this in the parentheses, I get 1 plus 2 is 3. And 3 squared just means 3 times 3, which is just 9. So my answer is 9 when I evaluated x as -2. So I would put that as my output over here. And this actually represents one of my points. Because don't forget, our points are made up of x and y value. So I have my first point. Now I need to get 1, 2, 3, 4 more points so I can have the graph of this function based on this domain. So now I'm going to take -1, put it in place of x here. So again, you can see that my -1 is what replaced x. It does not take into account that minus sign there, the negative. So be careful with that. Then I use order of operations. We got to do parentheses first. That's the same as 1 plus 1. And then if I add that up, I get 2. And I know 2 to the second power is 2 times 2. That's what that means, which is 4. So my output is 4 when I evaluate this number. And now I have my second point. So 3 more to go. So we're going to take 0 and put it in place of x. So I put a 0 here. So again, notice that this is what replaced x. There's no negative to worry about, so I don't have to worry about it really in this case. But now we get here, simplify inside the parentheses, we get 1. And we know 1 to the second power is just 1 times 1, which is 1. So my output when x is 0 is 1. So now I have my third point, 2 more to go. Now when x is 1, I replace x with 1. You can see here that's what will replace the x value. So I'm going to get y equals, following the order of operations, I do the parentheses first, that's 0. And 0 to the second power means 0 times 0, which is just 0. So my output when x is 1 is 0. And then the last one is when x is 2. So I'll replace x with the number 2. Notice that that's what replaces my x. Y equals, do parentheses first because that's the order of operations. We get 1 minus 2 is -1. -1 to the second power means -1 times -1, which is equal to +1. So my output when x is 2 is 1. And then that's the final point. So now we're actually ready to graph this. But before I graph this, one thing to point out is that in this equation, this function, I can see that my exponent is a 2. And if in the parentheses, I can see that I have the x term here. But that means that what I'm going to be sketching is, this is actually going to be in what we call a parabola. So my graph is going to be something like a parabola. And that's what it should look like when I start sketching it. So you can see our 5 points is going to look some type of shape like this. Again, if your exponent is a 2, that's your highest exponent. That's something what we call the degree of your equation. If it's the highest variable is a 2, or the exponent is a 2, we know that your graph will look something like this. Like, in other words, if you compare like this equation I can see my highest exponents are 1, so I know that it's going to be a linear equation. But once I start having equations where I have like 2 as my highest exponent, I know we're talking about a function that's going to look like this, a parabola, or in other words, a quadratic equation. So I'm going to take the first point, negative 2, 9, and plot that one there. So this is on GeoGebra's website, so I'm just going to go over here to the tool, the point tool. And again, this is going to be negative 2, 9. So I go, when x is negative 2, the output was positive 9. So I'll put a point up here. That's my first point. Second one is when x is negative 1, the output is 4. So when my input is negative 1, the output is 4. So I go to x is negative 1. And from there, I'm going to go up to positive 4 on the y. And you can see that's my second point. Third point, when x is 0, y is 1. So I go to x is 0, which is right here in the middle, in the origin. And then when x is 0, the y is 1, so I got to go up 1, put a point there. Next, when x is 1, I get y is 0. So I go to x is 1. And when I'm at x is 1, y is 0, which means I don't move up or down. It just stays there. So I'll put my next point there. And then the last one is when x is 2, y is 1. So I go to x is 2, y is 1, and you can see that that'll be about here. Let me just zoom in a little bit better. When x is 2, y is 1. So that would be somewhere right there. And you can see that we actually have like that U shape that I was talking about. So let me get the drawing tool. And you can see here, look, if I were to start drawing a line that kind of passes through the points, so this is done freehand, so it's not going to be perfect, but you'll get an idea of what your graph is going to look like. And you can see that it's going to look something like this. So this will be the parabola that we were talking about. So this is what I was mentioning earlier. So when you see the degree of your function is a 2, then we know it's going to be like a U shape.